Hi, it's me, Saul, here with vectors. Tired of your coffee table flying into your ceiling vent? Well, no more. With my patented vectors, you can now put force on things. With the power of gravity, your things stay where you put them. Here's how it works. Each vector has a direction, like how gravity pulls down on things, and a magnitude, which represents how intense the vector is. Think of it like gravity on two different planets. It acts differently everywhere. Putting it in a more handleable format for finding real-world applications of vectors, we can imagine each vector as a triangle. This line represents the whole vector, takes the magnitude for its value. Then here's where the direction is shown. Direction is written in angles, this angle being in one of four different quadrants, which we can also represent with directions. Direction ties into the legs, which represent distance, be it up, down, left, or right, with both the left, right, and up, down values being positive in the first quadrant, negative in the third, the left, right value being negative in the second quadrant, and the up, down being negative in the fourth. Forces also interact with each other constantly, be they adding on to one another or subtracting from one another. We can use a moving plane as an example of this sort of thing. Let's say this here plane is moving at a speed of 381 miles per hour on a southeast bearing of 17 degrees. And as it flies, we introduce another vector of a headwind hitting the plane with a speed of 57 miles per hour from a northwest bearing of 53 degrees. Now to find the ground speed and bearing of this little plane here, we use our patent-pending trig functions to achieve a proper vector notation. You following me, camera guy? Here. We take the reference angle of both bearings, plug it into our trig function. Since it's a trig function, try angles, not a bearing function like bears. That gives us 73 for the plane and 37 for the wind. We do the operations, boom boom, sine cosine. We have 381 cosine 73, negative 381 sine 73. Sine is negative because our bearing tells us that we are in quad 4. It's the same thing with the wind, boom, giving us negative 57 cosine 37, 57 sine 37. Do all these calculations, that gives us a ground speed vector, 65.871, negative 330.048. Now we got legs here, this triangle can walk now. We use two values of these legs to find the angular direction of the ground speed vector. Arctangent, negative 330.048 over 65.871. That gives us an angle of 78.713. Since we want the bearing and we have the angle, all we need to do is subtract the angle from 90. Boom! The ground speed vector is on its southeast bearing of 11.287 degrees. But wait, there's more. We only had the vector notation for the ground speed. We don't actually have it yet. However, with my patented squares, we can. Simply square both values of the ground speed vector, boom boom, add these, boom, and then we take the root of the result. Boom! There you have it. The ground speed clocks in at 336.557 miles per hour. And that's just a taste of all the wacky physics you can get into if you call now. If you call now, I'll even throw in a free set of notation brackets and squares. Trust me, this is a one-of-a-kind deal. I'll sell you these vectors for the low price of $2 million with shipping and handling. And remember, call now and I'll throw in a free pair of notation brackets and 20 squares. You'll be saying, "Oh God, where am I?" every time you use these things. Chip in next time where I sell you